Hello everyone, I hope you're doing well. Today I would like to go over the very basics of UV mapping and setting up materials in Maya. This will be a quick video as we will be going into more detail about these concepts in later videos. I've already set up my project, so next I need to make sure my textures are on by pressing this button right up here. And now everything here looks pretty dark, but thankfully there are already lights in this scene, so all I need to do is turn on the lighting visibility with this button right here. It looks like a light bulb, and now I can see my materials. Now let's go ahead and take a look at these first examples. As you can see, there's already a brick material set up on these example shapes. Now, these objects all have the same material, but notice how the textures appear larger or smaller on some of these objects, as well as how it seems that they're stretched in certain places, and how some of them have noticeable seams in some places. For example, right here on this cone, there's a visible seam right here. And on this cylinder, right here, there's a seam. This is due to how each object is UV mapped. To see the UV maps for each of these objects, we must first open the UV editor by going to UV editor. And now if we select each object, we can see that each one of these is spread out into different patterns in the UV editor, which pertain to how this material is projected onto the object. Go ahead and mentally leave a pin in that, as we will wrap back around to UV mapping in a bit. Until then, you can go ahead and close the UV editor. Now, what we are looking at in the viewport is a preview of this brick material, but our ultimate goal in Maya is to render high quality images with these materials. So we will want to take a look at what these will look like when they're rendered. To do that, go ahead and click this button right here in the top left corner of your viewport to enter Arnold View. Now, Arnold is a render engine which is built into Maya that allows you to render high-quality ray-traced images. We'll go into more details about how to use Arnold effectively at a later time, but for now, we're just going to use it to see what our materials look like while we are still working on them. Maya will run pretty slow and choppy in this mode. You wouldn't want to work in Arnold's view, but it's a good thing to just jump into really quickly to see how it will look as a final product. Once you're done with the Arnold view, go ahead and click that button in the top left again to return to the normal viewport. Let's go ahead and start by making our very first material on our own. We're going to go ahead and start with this cube right here, and all I need to do is select it, then hold right click, go down to assign new material, and it'll give me this pop-up right here. From here, I can go ahead and search for a certain material type. There are a lot of different materials in Maya, but for our purposes, we only want to work with AI standard surface. In general, since we're working with Arnold, we specifically want to work with materials that have this prefix AI, and we have to be really careful not to be confused with the Maya material that's just called standard surface. I want to make sure we go to the Arnold tab here and select AI standard surface. Now I've created and applied the new material, but how do I edit it? To do that, I'm going to need to click this button up here to open what's called the Hypershade window. The Hypershade window is a node-based editor for creating materials. To start editing my new material, I'm going to go ahead and select it here, and then I'm going to select this button with the two arrows to show the material and its input and output connections in the node editor. Now, this big rectangle that appeared in the middle here is our material, and all these dots here are slots where we can connect various inputs into the material. You can navigate through the node editor by pressing the middle mouse button and around, and the scroll wheel to zoom in and out. Over here on the right, we have our property editor, which allows us to manually set these inputs as well. And the first thing I want to do is to give this material a name. I'm going to type m_wood because we're going to be making a wood texture. Enter. And next, I'm going to go ahead and give this a color. So under the base tab right here, there is a input for color. And if we just double click this gray box here, a color wheel will pop up, which allows me to set a color. So I could set this to yellow, red, or blue, green, etc. And that's really nice if I just want to set a flat color, but that's not what I want to do. What I want to do instead is I want to apply a texture file. Now, this project already has a collection of texture files already in it. I just need to connect them. So to connect an image file, I need to go over here to the checkerboard button next to color. I click it, and it brings up this window to create a render node. And there are a slew of different render nodes I can choose from, but today I'm only going to be worrying about file node. Once I've created that file node, it's been automatically connected to my base color input. And if I select this node, its properties show up in the property editor. Whereas if I return to the material node, that's what shows up in the property editor. So I'm going to go back to file. And then here I'm going to select this folder button to select an image. I'm looking for bamboo, wood, semi-gloss, albedo. In computer graphics terms, the word albedo typically refers to simply the base color of a material. Once I found it, I'm going to open it. And then I can see my wood texture has just been applied to the cube, as well as to this example sphere in the hypershade. Next, I'm going to move on to the roughness of my object. That can be found here under the specular tab. Specularity in computer graphics refers to how much light can reflect off of a surface. And so roughness, as it follows, is how much of that light becomes scattered and blurred on said surface. Roughness can be set on a scale from 0 to 1, with 0 being a completely smooth surface and 1 being a completely rough surface. So if we take this roughness and we drag it down to 0, we look at our shader ball preview, we can see it's become very shiny. And then if I crank roughness all the way to 1, now it's very matte. The reflection is very flat. So I'm going to follow through with the same steps as before, but this time selecting the texture labeled roughness. I'm going to go to roughness, click the checkerboard button, press file, search for bamboo, wood, semi-gloss roughness. As you can see, this is a grayscale image. I'm going to open it. So when using a grayscale image like this for roughness, black pixels represent 0, while white pixels represent 1, and all of the gray values represent the values between 0 and 1. The result is a material with a varied roughness along its surface. So if we were to zoom in on this preview here, we can see that a lot of parts are shinier than others. Now there's one last texture I'm going to add, and that's going to be a normal map, which is a special image which allows us to fake details in our model, like bumps and grooves, by altering the way light reflects off of the material's surface. Put it very technically, normals in computer graphics are the orientation of a surface of a geometric object at a point on that surface. So we know from modeling that faces have normals which indicate what side of the polygon is facing outward. And the normals also determine whether there is a hard or smooth transition between faces along their shared edge. Materials can also have normals as well, and by using a normal map, we can alter the direction that light bounces off of a surface at specific points on the surface, creating the illusion of detail. To create a normal map, I'm going to go back to my material node. I'm going to go all the way down to geometry. And then down here, I'm going to select the checkerboard button next to bump mapping, open that up, and select file. Now this time it's created an extra node between the file and the material node. This is a bump 2D node, which, without getting into too many details, it converts a 2D texture into a bump map. Because of the way normal maps work, there are a couple of additional steps to adding one to your material than with base color and roughness. So first, with my bump 2D node selected, I want to change use as bump to use as tangent space normals. This clarifies that we're specifically using a normal map as our texture. Next, I'm going to go over to my file node, and it's the same as before. I'm going to open this up. I'm going to find my texture file, this time with the suffix of normal. After you've worked in 3D for a while, you'll begin to recognize normal map textures by their distinct coloration, with this shade of blue being the baseline for a lot of normal maps. Then after I've selected the file, I want to go down here to color space. And I want to change this from sRGB to raw. Without setting the color space to raw, Maya will incorrectly interpret the data from the normal map and it will come out really wrong. Once I've done those three things, you can start to see all these little grooves appear in the material in this preview here. I'll go down here, turn on Arnold view. And it's pretty subtle in Arnold. So I'm going to go to my bump 2D. And just for the sake of experimentation, I'm going to turn the bump depth way up. The effect is extremely subtle when we take it into Arnold, but often subtlety is making realistic textures. But if you look in a lot of these little grains, you can see just a little bit of highlight on the ridges of these little grains where it seems to divot in now. If you turn off the Arnold preview, it's actually a lot more apparent. You can see when looking at just the regular viewport modes that the normal map is working really strongly. It's just very subtle when it comes to actually rendering it. I'm going to turn bump depth down one again. And I'm pretty comfortable with that, so I'm going to move on to the next problem. I'm going to go ahead and close the hypershade for now. I'm going to select this cube. And all I have to do is apply the same material, then UV map the cube. So to apply a material we've already created, I'm going to hold right click. I'm going to go down to assign existing material. And I'm going to find M_wood. Now we applied it, but it doesn't seem to be showing up. That is because this cube has no UV map. And we can find this out by going to UV editor. And while we can see what texture applied to it, we can see what the material is supposed to look like. We don't see any pattern here like we saw with these objects. See all these faces here, here, and here. There's nothing here. So because of this, we need to make the UV maps ourselves. So I'm going to go ahead and dock the UV editor right here, right next to my viewport. I'm going to minimize the bar on the right by clicking the tab. And if you don't have this UV toolkit, go ahead and go to Tools. And this button right here will toggle the UV toolkit. I'm going to minimize my outliner as well to give myself as much space as possible. So, what is a UV map? A UV map is a projection of the 3D surface onto a 2D layout, which acts as a guide for where materials be applied on the 3D model. The reason why it's called a UV map is simply that U and V are the names of the two axes on this graph, as opposed to X, Y, and Z, like in 3D space. I'm not sure why it's become known as UV mapping beyond that, so just kind of roll with it. Now, that sounds really abstract, so what's a better way to think of this? One really good analogy that I like to go back to is to think of it as the way that clothes are made in real life. So first a 2D pattern is created, and then the fabric is cut and stitched together into a 3D form. Consider UV mapping to be like making a pattern for clothing, but in reverse. You got the clothes, and now you're cutting it up into a flat shape. Another way to look at it is like a cardboard box, which starts out flat, but it needs to be folded into a 3D shape. Once again, consider it like designing such a box, but in reverse. With that in mind, let's go ahead and UV map this cube. So first select the cube you want to UV, and then in the UV toolkit, open up the tab labeled Create. Here there are multiple algorithms for creating UVs, but for now let's just use automatic. Once you've done that, you should see your texture now applied to the model. However, you'll notice that none of the sides line up with each other like they do on the other cube. That is because the automatic UV function created 6 separate parts, which are called UV shells. UV shells are a type of component which can be selected sort of like how vertices, edges, and faces can be selected. But instead, UV shells are groups of faces which are all connected to each other via their UVs. These UV shells can be selected by going to the UV editor and holding right-click to select UV shell mode. Now, if I want these faces to smoothly transition between each other, we'll need to stitch them together. To do that, I'm going to go ahead and enter edge mode. And then I'm going to select one edge between two faces that I want to line up. Then I'm going to go to the UV toolkit. I'm going to go down to cut and sew. And I'm going to select stitch together. And you'll notice down here that one face snapped up here. And now these are both connected at the edge. Go to UV shell again. I can see that they're now just one shell. If I regret the stitch I've made, I can always go back to edge mode. And then with that edge selected, I can go to cut and go back to UV shell mode. Those are two separate shells again. So I'm going to go ahead and repeat this until all of these faces make up one continuous shell. The goal with this is to balance having as few visible breaks or seams in your texture while still avoiding distortions. Because if I were to, say, grab every single edge and then hit sew, which is right here just above stitch together, there would be no more seams at all, but the texture would be very warped. The sew tool, by the way, is similar to the stitch together tool, but the sew tool will not move the entire face or shell. It will instead simply stretch your faces together that forces the edges to merge. If I were to select this corner, one edge here in the viewport, two edges in the UV editor, if I were to sew them together, all these faces are now out of shape because I've forced these two edges to combine. So now that I have the UV shell that I want, I'm going to rotate this. And while I'm rotating, I'm going to hold J to rotate in 15-degree increments. I'll get to here. I'm going to slide this down. And I want my UVs to all fit within this grid right here. This range of 0 to 1, both vertically and horizontally. I'm going to scale it down. And I'm trying to get it as close as possible to the edges so I make the most of my space. Typically, you do not want your UVs to extend outside of this range, especially when performance is a concern. Once you're done, go ahead and go back to object mode. And you'll want to clear the history after you do any changes to your UVs. And we can go ahead and move on. Next up, this cylinder, we're back with the brick texture. And all we have to do is fix the texture distortion on this cylinder. So this texture is very stretched out. That's because when we look at this, we'll find that the faces on the side here are being compressed, and they're a lot thinner than the faces that we see in the 3D view. So a really easy way to fix this, just select these faces, or I can select the UV shell, and I'm just going to scale them in the X direction. I'm going to find that seam right here. You can tell where seams are if you can find whichever edge appears in white rather than blue. These seams will only appear though if you have the UV editor open. Anyway, I'm going to continue to scale this up. X direction. Like as close to that edge as possible. Thankfully, because this is a tileable texture, if I meet the edges on both sides, it'll look like it loops around, and it'll practically erase that seam. And if I want, I can also scale this up. And then I'm going to grab this disk and move it down here, this up, so that I have a little bit more space to scale this vertically. Trying to get that concrete edge to kind of meet right here at the top to sort of disguise the seams between the sides and the caps here. And it's by no means perfect, but it's a lot better than it was before. Most important thing is that I've solved the texture stretching on the x-axis, which was so severe. So now I'm done with that, I'm going to move on to the next problem. So once again, we will be creating a new material and we'll be UV mapping this anvil from scratch. So this time I'm going to start with the UV mapping. And like before, I'm going to hit automatic. Now, if I had a texture on this already, I could be mindful of stretching and distortions. I don't have a texture on this right now. So in lieu of a texture, I can press this checkerboard button right here to apply temporary textures just to see how these UV maps are looking with the texture on it. And it's a little bit hard to see with it, so I'll turn it off and on periodically. Now, when it comes to UV mapping, there's no perfect answer to how you should UV map your model. So just try to go for what makes sense while aiming for that balance between removing seams and hiding them, as well as avoiding distortion. For a more complex shape like this, I don't want to end up with a single UV shell like I did with the cube. So I'm also looking to maximize my usage of this space in 0 to 1 coordinates. I'm also going to turn on my symmetry. Oh, looks like I should be using Object X for my symmetry. And I will probably be cutting just as much as I'm stitching together. Here, this seems like one plane to me as far as the shape language goes. So it doesn't make sense why there would be a cut here and a cut here. So I'm going to go ahead and stitch those together. Same with the other side as well. Where I can, I'm going to try to hide a lot of my seams on the other side of things, while I try to remove seams that are a little more visible. And sometimes I end up with bizarre UV shells like this. And in that instance, I'm going to go to UV shell, open up the unfold tab, and hit unfold. And what that does is that it adjusts the shapes of all these faces so that they have as little stretching and distortion as possible. All right, once I have cleaned this up a bunch and gotten these UVs to a point where I think that I have hidden most of these seams, the last step is I want to organize this somehow. Now, again, my goal here is to take advantage of as much of this 0 to 1 space as possible, but that can be hard to do by hand. The easiest way to quickly organize these shells is to select all of my shells and then go down here to arrange and layout and hit layout. This function sorts all of your UV shells into the most optimal arrangement, take up as much of the 0 to 1 space as possible. This allows you to get as much pixel information out of your textures as possible without wasted space. If the layout tool isn't working exactly as you would like it to, you could hold shift and then click to get the layout UV options menu. That will allow you to do things like add padding to your shells. So let's say I add a shell padding of 5 and then I hit apply. And now there's a little gap between my shells. Or say you could check this box to allow the layout tool to rotate your shells, which can be really nice for taking even more advantage of the space. So definitely check that out to see how you can fine tune your layout settings. And once I've finished with my UVs, I'm going to go back to object mode. Then I erase my history. And we're going to apply new material. So assign a new material. Go to Arnold. Once again, we're looking for AI standard surface. Open the Hypershade. And I'm going to select my new AI standard surface. Click the input and output connections button. And I'll give this a new name. Called M_anvil. And most of this will be the same as before, but I'm going to jump straight ahead to what is new about this. material is we're going to apply a metalness texture now. So metalness, like roughness, is on a 0 to 1 scale. So 0 equals no metalness and 1 equals entirely metal. So if I were to turn this up in the material preview, it looks like a totally chrome ball now. If I turn that down, it looks like plastic again. Same thing if we look at Arnold. Turn on the Arnold view. That anvil is suddenly super reflective. Remember to metal this down. Back to plastic. So I'm going to select the checkerboard button again. File. I'm looking for beaten up metal 1 metallic. And once again, like roughness, this is a grayscale texture. And so some parts of it look less metal than others. And then I'm going to just proceed through the rest of the motions, applying color and roughness and normals, just like before. Don't forget with the normal map, for bump 2D, you have to select use as tangent space normals. And then in the file node, you have to select your normal map, but you also have to select your color space, set it to raw. Otherwise, your normal map will break. All right, let's give that a look in Arnold. Here we can see that normal map really doing a lot of work. You can see the slight shadows in the big dent right here. That's looking very nice. I'm happy with how that turned out. I'm going to leave the Arnold view. And I'm going to move on to the next thing. We're not going to need the UV editor anymore, so I'm just going to yank this out, close it, same with the toolkit. Just need our viewport and our hypershade now. So our next objective is to create another material, and this one needs to be transparent. So I'm going to select this again, a new material, Arnold, AI standard surface. Select the AI standard surface material, select input and output connections, and then give this a new name. Oh, it's M_glass. And this one will be really easy. We don't have any texture files to apply. All we have to do is go to transmission, increase the weight to 1. See right here, now we can see through this object. Arnold. And when we go to Arnold, it looks like glass. And that's literally all we have to do. So then, moving on. And the last one, create a material which glows with a color other than white. So very similar to the last one, I'm going to go ahead and last time assign a new material. Go to the Arnold tab, select AI standard surface. I'm going to select it up here. Input and output connections. Give this a name. Let's call it _glow. And then I'm going to find the emission tab. And there are 2 values here we need to work with. I'm going to turn on the Arnold view preemptively. It's very dark in there right now. Until we turn up the weight on emission. And now that texture is no longer reacting to external lights. There's no shadow on it. Instead, it's emitting its own light. And then if we go over here to color, we can change the color of the light that is giving off from this material. And that's looking very nice, but let's say I wanted it to glow even more. I want it to be very intense. Now the slider is already dragged to the maximum here at 1. But if I go in here and type any value I want, I can exceed the limits of the slider. And go up to something like 5 or even 10. And I can get way more intense values. Just as a quick tip, this applies to a lot of sliders in Maya. So if you're ever frustrated with the limitations of a slider and it's not giving you the sort of high value that you want, go ahead and just type in a higher number. And usually Maya will let you bypass the limits of the slider that way. Anyway, that's the end for these problems. Materials and UV mapping are a huge facet of Maya on their own, and this is just barely scratching the surface. So do some exploring on your own once you've got the hang of things, and we will be going into greater detail on UV mapping and materials in future videos. Until then, I wish you luck, and I hope you have a good day.